So far, our discussion of entropy has focused on the entropy of the substances present in the system. To consider the total entropy change of a region, we must also consider the entropy change in the surroundings. Okay, consider that this is an exothermic region, the energy released to the surrounding. Okay, now we want to find the entropy change of the surrounding. Okay, so what happened when the energy released to the surrounding? The surrounding will receive heat, right? So for the system, the delta H is negative since this is an exothermic region. But for the surrounding, it receives or gains energy. So now we can see that the surrounding, the entropy change of the surrounding will be proportional to the delta H system. But you can see here that there is a negative sign in front of the delta H. That means if the system releases energy, then the surrounding will receive energy, or the opposite of the system behavior. Okay, so that's why we give the negative sign in front of delta H. But for example, if it is an endothermic region, the delta H positive. That means the system gain energy from the surrounding. That means the surrounding will lose energy. So that's why if the sign of delta S is positive, the sign of delta S surrounding will be negative. Okay, negative with positive will be negative. Why? Because the surrounding lost heat given to the system. Okay, so once again, the entropy of the surrounding is proportional to the negative of delta H system. Now you want to see about the change in entropy with temperature. You can see through this that the change in entropy is inversely proportional to the absolute temperature. Okay, to understand the relationship between the entropy change of reaction and entropy change of the surroundings, it is helpful to recognize that the impact of a transfer of heat to the surrounding depends on the current state of disorder in the surroundings. If the surroundings are hot, the addition of a little extra heat makes only a little difference to the disorder. Okay. Once again, only a little extra heat just makes a little difference to the disorder. But if the surroundings are cold, what happens? If the surroundings are cold, the same amount of heat could cause a dramatic change in entropy. Okay, do you understand? So once again, it depends on the current state of disorder in the surrounding. If the surrounding is hot, the addition of little extra heat makes a little difference to the disorder. But if the surroundings are cold, the same amount of heat cause a dramatic change in entropy. Okay, you can see this picture, these two pictures. A busy street is a hot and disordered environment. A quiet library is a cold and ordered environment. Which do you think would cause more disruption? Yeah, a loud voice, for example, in a busy street or in a quiet library. Okay, So you can understand that the change in entropy, yeah, will be inversely proportional to the absolute temperature. Okay, so if the temperature already hot or high temperature, then the delta surrounding will be small. But if it is cold, the delta surrounding will be high. Yeah, so inversely proportional to the temperature. Understand, yeah? So we can see once again the delta S surrounding equals to negative of delta S system. We also see that the delta S surrounding is equals to 1 over T. Okay, so we can propose the formula of delta S surroundings would be negative of delta S system over T. And the T must measured in Kelvin. Entropies are generally expressed in the units joule per Kelvin mole. So, but for delta H, usually in kilojoules. Yeah, kilojoules per mole. So when we perform the calculations to find the delta surrounding, the delta S reaction should be multiplied by 1000 because we should convert kilojoules to joules. Okay. Once again, the negative sign in front of delta S reactions is part of the equation and not the sign of enthalpy change. So if the delta H is negative, so the whole negative delta S over T will be positive because negative, negative. Okay, let's practice. Calculate the entropy change of the surrounding for this region. So delta S surrounding once again is minus of delta S region over T. So minus of, and this is in kilojoules, you should convert to joules, over, this is standard, right? So 298 Kelvin. Okay, the result will be, don't forget the units, joules, Kelvin minus 1, mole minus 1. Okay, or joule per Kelvin mole. So this is how we find the delta S of the surrounding. This is same. Let's find the answer. Delta S reaction over T. So delta S of surrounding. Okay. Do you get the same answer? I hope. Okay, there are two more questions here. One carried out at 0 degree. One carried out at 300 degree. Okay. In this question, you can see that we assume that the value of delta H does not change with temperature because actually it will change. But in this case, we assume that it not change. So the delta surrounding will be this over T in 273 Kelvin. The result is positive 1441. And I got the same answer for this. Okay, let's take a look once again. 307.9 times 1000 over 573. Oh, once again, 307.9 . times 1000 over 573. Positive 537.3, yeah, 35. Okay, joules, Kelvin, minus 1, mole minus 1. Minus delta H over T. Okay, for this is negative, should be negative, yeah? Because, once again, minus delta H over T. So, because this is positive, the value of delta surrounding will be negative, yeah? But this is positive.